Behind our Milky Way lies a truly strange structure. Some time ago, astronomers discovered a region in space that does not attract surrounding structures. Instead, it appears to repel them. Now named the Dipole Repeller, this mysterious area remains a major focus of astronomical research. What's particularly astonishing is that this center of apparent repulsion exerts a gravitational influence as strong as that of the well-known Shapley Attractor. But why is our galaxy being pushed through the universe? Could this be a sign that the Dipole Repeller is somehow defying gravity, reversing its laws? Stay tuned as we dive into one of the most intriguing cosmic discoveries of our time: our galaxy's journey through space. The Milky Way is not a lone traveler. It belongs to a complex, hierarchical structure of galaxies and galaxy clusters. For a long time, scientists believed it was part of a massive region spanning 520 million light-years, known as the Laniakea supercluster. However, that classification is now under question, as we'll explore shortly. What we do know is this: our Milky Way, along with the rest of the local group, is moving through space at about 630 kilometers per second, or roughly 2 million kilometers per hour. For years, astronomers believed this movement was largely driven by the gravitational pull of the Shapley Attractor, a colossal region 700 million light-years away, teeming with galaxies. But a groundbreaking study by Yehuda Hoffman and his team from the Hebrew University of Jerusalem turned that assumption on its head, discovering the Dipole Repeller. To understand the Dipole Repeller, researchers traced the movements of galaxies using data from multiple telescopes, including the Hubble Space Telescope. They created a high-level model of motion in our cosmic neighborhood, mapping out speeds and flow lines. The results were shocking. Not all galaxy motion pointed toward the Shapley Attractor. On the opposite side of Laniakea, they found another region where motion lines seemed to converge. But instead of attraction, this region exhibited repulsion. Hoffman explained, "We found that our Milky Way is moving away from a large, previously unidentified region of low density in space. This Dipole Repeller is sparsely populated, containing far fewer galaxies than average. Yet, calculations showed that its effect on our movement is nearly as strong as the gravitational pull of the Shapley Attractor." This was the first time astronomers had identified such a repelling zone in the universe. Is it really repelling us? So, what does repelling actually mean here? Are anti-gravitational forces at work? Not exactly. On a cosmic scale, two forces dominate: gravity and dark energy. In this case, only gravity matters. And according to the laws of classical physics, gravity only attracts. There is no such thing as gravitational repulsion. So how does this make sense? The Dipole Repeller isn't actively pushing us. It's simply not attracting us. Due to its low mass, there is no gravitational pull. The Shapley Attractor, on the other hand, is incredibly massive and pulls us toward it. The result is a gravitational imbalance. We're drawn toward mass and move away from empty space. To visualize this, imagine a rubber sheet. Heavy balls placed on the sheet create dense, gravitational wells. A smaller ball, representing our galaxy, will roll toward the dents. If there's no mass on one side, there's no dent, hence, nothing to keep the ball there. It rolls away, not because it's pushed, but because it isn't pulled. So the repulsion is an illusion, a label that describes what's observed, not what's physically happening. The Dipole Repeller doesn't repel anything. It simply lacks the gravity to hold us in place. A major scientific breakthrough. Even so, this discovery is hugely significant. It reveals that the absence of mass can be just as influential as the presence of mass when it comes to the motion of galaxies. Our Milky Way is not just heading toward dense regions, it's also moving away from voids. The combined effect of the Shapley Attractor and the Dipole Repeller creates a motion pattern resembling a dipole, a positive, attractive, pole, and a negative, apparently repulsive, one. Does the Milky Way even belong to Laniakea? This discovery also raises a deeper question. Where do we truly belong in the universe? For years, it was assumed our galaxy was part of the Laniakea supercluster, a system of around 100,000 galaxies. But a new study from the Cosmic Flows 4 project, led by Aurélien de Lettre at the Leibniz Institute for Astrophysics in Potsdam, challenges that notion. Researchers analyzed the movement of over 56,000 galaxies, identifying 17 basins of attraction, gravitational zones where galaxies converge. One of the largest is the Sloan Great Wall, a titanic structure even more influential than the Shapley supercluster. Their findings? About 58% of our galactic motion is directed toward the Shapley region, only 40% toward Laniakea. This means our galaxy may be more influenced by the Shapley Attractor than previously believed, and may not even belong to the Laniakea supercluster at all. Redrawing the cosmic map. This is more than a technical adjustment. It's a fundamental shift in our understanding of the cosmic landscape. The old, simplistic model of superclusters is no longer sufficient. The universe is far more complex, filled with invisible structures, mass imbalances, and dynamic gravitational flows. And right now, our Milky Way is surfing one of those flows, drawn forward by mass, drifting from emptiness, and carried through an ever-shifting cosmic current that continues to redefine what we know about space.